All right. So this is the assignment called Intro to the Planets. And on number one, I just want you to list the names of the planets in order from the sun outward. Remember, if you don't know those already, use that memory tool. My very excellent mother just sent us 9 pizzas. Just take that sentence and convert that into the list of planets. And we're going to do number 2 together. So part of this assignment we'll do together, and part I'll turn you loose to just look things up online. So basically, when we look at the 9 planets, to start with, we're going to subtract number 9 because we've reclassified Pluto as a dwarf planet. It doesn't quite fit the definition of a planet, and it doesn't follow the pattern that we see when we divide the planets into these 2 groups, the inner planets and the outer planets. So the inner planets are also called the rocky planets. Actually, they have 2 different names. Rocky planets is one, and the other is the terrestrial planets, because they're like Earth. Terra means Earth, so terrestrial means related to the Earth. Meanwhile, the outer planets are known as the gas giants. And then each of these 2 groups includes 4 planets. So list the first 4 planets in the inner planet section. My very excellent mother. And list the 4 outer planets. Just sent us 9. We're going to skip Pluto entirely. That's why I said just sent us 9 and kind of broke it off. We don't know what she sent us anymore. Part of the problem is that there are more than one dwarf planet. We're starting to discover more out there, and they just don't really fit the definition of a planet based on their orbits and their size and their location and their composition. We think we'll be discovering more in the future, but they're very small, they're very far away, and they're very dark, so it's hard to find them. Okay, now what about size for the inner planets in general compared to the outer planets? What do you think? Absolutely, smaller for the inner planets. Why do you think we call the outer planets the gas giants? The gas giants, right? Because they're bigger. Let's see, what do you think about temperature? If they're closer to the sun, in general, their temperature will be, it's going to be warmer for the inner planets and colder for the outer planets.
What is the alternate name for the inner planet?
Either the rocky planets or the terrestrial planets. Sorry?
The inner planets are how much smaller? Smaller?
Oh, just say they're smaller. They're a lot smaller. Like it would probably take, I don't know, 100 Earths, maybe 500 Earths to equal the size of Jupiter. And you don't have to memorize any numbers here. It's more like just overall generalizations in comparisons. If you want numbers, you can always look that up, huh? But I would like you to, in general, know these things. What do you think the inner planets are mostly made of? Considering that they're called the rocky planets, they're mostly made of rock. Of course, sometimes that rock is in the liquid state, like the magma underneath the crust, but it's still rock, even though it is molten rock. What about the gas giants? The outer planets are mostly made of gases, especially some of the lighter gases like hydrogen, which is, if you remember, hydrogen makes up about 90% of the sun, right? So if it also makes up 90% of Jupiter, doesn't that suggest that Jupiter was almost a star? We think Jupiter just was a little too small to be able to start the hydrogen fusion process. There wasn't enough gravity to force that hydrogen together to release the energy and light that happens when a star conducts fusion. So sometimes Jupiter is considered a failed star. Yeah.
What if it did turn to a star? Would it still rotate around our star?
Be careful of your use of the word rotate. It doesn't rotate around the sun. This is rotate, and this is orbit. Or revolve is actually the proper name for orbit. Okay? But I'm not too worried about that word revolve, but I do want you to use rotate properly. And I would say yes, if it was a small star, it would still revolve around the sun. It would still orbit the sun, because we're talking about the gravity is much bigger on the sun, so it would keep Jupiter in its orbit. If there was a way to compress it down. In fact, you guys know the science fiction story of 2001, 2001: A Space Odyssey, which when it was written, it was like 2001 was way in the future. Now we're past that. In that story, there's actually an alien race that turns Jupiter into another star. So, at any rate, where are we? Number of moons. Well, let's see. Mercury has no moons. Venus has no moons. The Earth has one moon. Mars has two moons. Jupiter has dozens of moons. Saturn has dozens of moons. So for number of moons for inner planets is few or none. And for outer planets, it would be many. Same is true for Uranus and Neptune. Do any of the inner planets have rings? No. So none of the inner planets have rings. And actually, all of the outer planets have rings. The biggest ring system, of course, is on Saturn, but the other planets also have small rings that we didn't even know they were there until we flew spacecraft over there. And why did the rings happen? That's a great question. And there's basically two possibilities. One is that a ring was a moon that broke apart. And the other possibility is the opposite, where it was debris that never compressed into a moon. Does that make sense? So the rings are not like a solid thing, are they? They're fragments of rock and ice of many sizes, ranging from a grain of sand up to the size of a mountain. So we think that they're either a moon that didn't quite form or a moon that got broken apart. And it also suggests, especially if it's a moon that broke apart, that they weren't always there and they won't always be there. It's just that right now we happen to see rings around Saturn very clearly, but in the past it might have been a moon, and so you wouldn't have had the rings of Saturn. And in the future, all those little particles could get pulled by Saturn down into the planet, and so the ring would be gone in the future. So in a way, we're kind of lucky to be able to see it like that at all.
So why exactly did the rings form into rings?
Well, the gravity is keeping each individual particle in orbit around the planet. So each individual particle acts like a different moon orbiting the planet, but they have not consolidated to form a separate independent moon. Or it was a moon that broke apart. Maybe there was a collision between a moon and a comet, and it fragmented that moon, and the debris just kind of spread out And it turns out that with gravity, there are certain locations that material tends to get concentrated. Very much like with currents in the ocean, tend to move materials to certain places. So have you heard of the Great Garbage Patch?
Yeah.
Okay, so that's because the currents are spiraling around and it brings all the garbage and it gets stuck there. And the same thing could happen with the debris left over from a moon. The way gravity pulls on it, it keeps it at that one distance.
That's what they're all pretty much.
It's like a right. It's partly the amount of gravity pulling on it, and partly the momentum that they have in their motion. If their momentum was more towards the planet, they'd be destroyed by falling into the atmosphere, right? Or if they had enough momentum and were moving away, they'd be lost to space. And this probably does happen to some of them over time, which is why the rings could well disappear in the distant future.
So it's like how when you have a ball and if you put water and spin it, it'll a lot of the water flies off towards the middle part of it.
Right. Yeah. Yeah. Yes, sir.
So like a rock could just go to Saturn.
Well, we think that there might be a solid core deeper in there. Yeah. It's unclear at this point. We actually dropped a robotic spacecraft into the atmosphere recently too, and we might have done this more than once, but recently they did it again. And it transmitted signals for as long as it could, but the atmosphere is so thick that the pressure builds up and builds up and builds up. And you know how your ears pop when the pressure changes? It was enough pressure that it just collapsed the whole spacecraft and destroyed it. So we only have so much direct evidence inside. And I don't know, it seems like they should be able to send like radar through it and find out if it has a solid core or not. But I leave that to the person that's going to do their poster on Saturn to let us know. Is that Brittany? Are you doing Saturn?
Yeah.
Okay. All right, shall we move on to number 3? Oh, you're doing the moon. Okay, right. Let's move on to number 3.
So weird.
It's a very weird thing because partly we think that the world is, that nature is, that the universe is the way that we experience it. But is that the only thing that's out there? There's so many other ways to experience what's beyond our body's capability, like X-ray light, right? Or we can go the other way too, to the very tiny things, the atoms and the protons and the quarks. You know, whether we expand out to the very large or shrink down to the very small, it becomes a very different universe than we're used to thinking about. And it becomes mind-boggling to try to figure that stuff out. And the same is true for time, in the past and in the future, to think about what it was like here 500 million years ago, stuff like that. What will it be like 500 million years from now? I don't think we can assume that it's always been this way and it always will be this way, right? Yeah.
Would it be possible to see the reflection of our Earth off a distant star? Because, like, if it's light years away and we're able to see back ourselves, it would just be a whole different planet, right?
Oh, like if you were to have a big telescope and let's say there's some planet that's got oceans on it and it's reflecting the Earth on the ocean. Well, that would be interesting because if it was 200 light years away, you'd be looking 400 years in the past because it would take 200 years for the light to leave Earth, hit that planet, and 200 years for it to get back to us. And so you could see what was happening 400 years ago, right? You could see Plymouth Rock and the Pilgrims arriving. That'd be crazy.
That's just like
A different kind of time travel, I guess, huh? How about that? You could write a whole TV series about time, about learning about the past, and you started off with some kind of spacecraft that can travel faster than light and set up big mirrors that reflect Earth's light back to us. Yeah. All right, let's do number 3. Ancient people thought that there were only 5 planets: Venus, Jupiter, Saturn, Mars, and Mercury. Now, this list is in order for how bright they are, because this is the list from ancient people's perspective, looking from Earth without telescopes, right? How did they know? Because the next sentence, even without telescopes, the ancients knew the planets were different than stars because stars always stay in the same location, while planets slowly change position. In fact, the word planet comes from a Greek word that means to wander. The planets are the wanderers. They move from one part of the sky to another part of the sky. Remember how it was all these people were excited last fall about the alignment of Jupiter and Saturn? How they got really close together? It's because they're moving past one another, right? But stars don't do that. Stars are, for an entire human lifetime, for all of human history, the stars have been in the same place. Okay? It's possible, but not likely. There would have to be a force to get them moving in that way. It's much more likely that a comet can crash into a planet. And we're going to talk about that next class.
It's like big, like big it is. They're like, yeah, I can't think of it.
So you have two questions to answer here on number 3. Why do you think that the ancients did not include the rest of the planets in their list? The first answer should be specific to Earth. Why did the ancient people not include Earth in their list of planets? And your second answer should be, why did the ancient people not include Uranus and Neptune, and Pluto for that matter, in their list of planets?
They move like pretty fast, or just
like,
every night you can kind of see.
Yeah, it's not like you go outside and you watch the planet moving across the sky. But if you go out one night, sometimes when they're fast, the next night you can see it's not quite in the same place. But that's when it's moving fast. Normally it's like it's there for a month. But then you notice, oh, it's actually a little bit over here now. Like a month later, you notice that it has moved. But sometimes you can notice night to night this motion. Like when Jupiter and Saturn lined up with each other, you could tell the movement from one night to another, because it was like they were here, and then the next night they were here, and the next night they were here. So you have to look regularly to notice that motion. And of course, the ancient people didn't have city lights interfering with their view of the sky, right? So in some ways, they were much more in tune than the average person is now. All right, number 4, are we ready?
Are they so bright as the sun?
The planets are all reflecting sunlight. Yeah, it's two things that make them look bright to us. One, they're reflecting the sunlight, but they're close to us compared to the stars. They're close to us. If they were as far away as the stars are, we wouldn't see them at all, because they're not making their own light. They're just like big mirrors up in the sky, just like the moon is, reflecting sunlight back to us. None of that moonlight is coming from the moon. It's bouncing off the moon, right?
I can't think of it.
No,
Like on this huge rock, and then there's
and we're spinning,
yeah,
and we're flying.
or a huge, a huge sun.
Yeah, that's burning.
Oh,
Yeah. Once modern astronomers started making careful observations of the movements of the planets, they realized that something was not quite right. Based on the physics of motion and gravity, they could tell that Saturn's orbit was influenced more than just the sun and the other known planets. So check this out. If this is Saturn, and we know that it should be moving like this, I'm the sun, it should be moving around me, right? And here's Jupiter. When Saturn gets close to Jupiter, we can see a little change in its orbit because of Jupiter's gravity. Does that make sense? Saturn's coming along, and then there's a little dip when it goes by Jupiter, right? But not only was it doing this when it went by Jupiter, it would then go like that. What does that tell you? One more time. I'm the sun. Here's Jupiter. Here's Saturn. Saturn's orbiting around me. And then Jupiter pulls it in a little bit. It goes back to where it was. And then it goes over there. Yes, exactly. There's something else pulling on it out there, huh? There's the gravity of something else pulling it out on there. And so by analyzing very carefully the motion of these planets, we could tell that there was something that we didn't know about yet. Some gravitational force was being exerted on Saturn, and we didn't know what it was. So they started looking for new planets beyond Saturn that would provide that extra gravitational influence to explain its movements completely. Sure enough, they found them. But how could they tell when they found a new planet in their telescope? What I would like to suggest is we come back to number 4 after we do number 5. So look at number 5. These diagrams are based on photos taken by Clyde Tombaugh through a telescope when he discovered Pluto in 1930. Wow, we haven't even known about Pluto for not even 100 years yet. Notice that all of the stars stay in the same place in the two different photos, but one point of light has moved. This was the proof that Pluto was orbiting the sun out beyond Neptune. Recently, astronomers realized that Pluto didn't quite fit the description of a planet, and that it should be considered to be part of another category of objects called dwarf planets. Pluto's diameter is actually smaller than the distance from LA to New York. Several other dwarf planets have now been discovered, and Pluto is more similar to them than it is to the other planets. So if you look at these two photos, taking 1 week apart, basically 6 days apart, your task is to find Pluto and circle it in both photos. How can you tell that it's a planet? Because the planets do what? That stars don't do. Like right here, look at these two. Do we also see them right there? There's no change in them, so those are stars. If they don't change location, then they are stars. But you should be able to basically check off every dot on there as being a star, except for one of them that's found in two different places in those two images. And that would be Pluto. And I want you to circle Pluto when you find it in both images. When you're done with that, go back to question 4, because basically you've done the same process that an astronomer would use to find a planet, or a comet for that matter. All right, are we ready for number 6? This one you're going to do on your own just by searching online. If I was you, I would just put into my search bar planet with, and then I would change what it says. Planet with fastest orbit, planet with largest size, planet with no atmosphere, like that. But I have to show you something on this chart. So have a look here. Every answer on the left is going to be the name of a planet. On the right, extra info, for the first bunch, it says none, 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 none. But down here, you have to start doing something. So which planet has a moon that might have a liquid ocean? Well, you give the name of the planet here, and then you give the name of the moon over here. Does that make sense? Some of these things have two answers. Always the name of the planet on the left, and then some different kind of information over on the right sometimes. You got it? And so what we're gonna do is spend maybe 20 minutes. I'm gonna give you to work on this on your own, and then we're gonna come back and we're gonna talk about comets. And then for the rest of the period after that, you'll have to work on your PowerPoint. All right? So finish this chart, save it, and turn it in, and then we'll come and talk about the comments.